In this particular case, this is the Internet of Food at Farms. It's a large-scale project funded by the European Union. It has a significant budget of over 30 million euros, and also its participants are over 70 organizations, research organizations, and technology companies, and most importantly, the farming community. In this particular project, we are trying to demonstrate a combination of technologies, which is classified as the Internet of Things, and how it plays a role in helping the farming community increase the production efficiencies of their assets and their businesses. And there's an awful lot of different elements to the whole of the project, and it's important that we communicate to you that the technology development is very much a combination of a number of different stakeholders across, from technology right through to the end users, because the impact of the technology on the practices is much more important, and the usability of it, the maintenance, the deployment, the interaction with it is really part and parcel of the program. So it's not an isolated technology-driven project. It has a lot of different stakeholders, and that's a great exemplar of, through many years of experience, of how to develop solutions which are fit for purpose. Now, at the heart of this is a series of use cases, and it's very comprehensive in that it addresses a number of different segments of the agricultural business, agricultural community, from fruits to arable to meats to vegetables. And the particular one this morning that we will major on is the dairy trial, which is a multi-partner, like all of them indeed, are a multi-partner consortium of people from farmers and supply chain, from the technology infrastructure providers, from people who systems integrate, and also some of the academics who provide the new set of technologies that might be applicable and might be trialed across particularly operational environments. So what I would like to just highlight to you is this ecosystem. There's a framework of people drawn from the operational farming community right down to the basic device people at the bottom, but we're all in a group which are providing the guidance. The farmers provide the guidance for the technology, so the technology serves the needs of the farming community rather than the other way around. And the evaluation of it, that is very important. So we're looking at integration, so we need to be able to provide a cost-effective solution. So any vendor of technology needs to be able to provide a solution for the farmer. That's how we drive down costs. The business support is about nurturing particularly nascent technologies into commercial entities or robust commercial solutions that can be offered to the farming community. And it's all that multi-actor environment that the project has managed to foster. So we've got this collaboration space, and we're all pulling in the same direction, which then lowers the barrier to understanding the impact, and also lowers the barrier to adoption of these systems. So the vision is data-driven. So it's all about collecting data, particularly from processes of individual animals, and using that data to inform the decision-making of the farmer. So we've got autonomy is important here. We want to hide the complexity behind these systems, so we present information fit for purpose from the farmer. And the principle is that we understand the animal, the dairy cow in this particular case, and that information then could be very, very important for the farmer to optimize yield, etc., and health of the animal, but also can be shared further on down the value chain to optimize the path from the farm itself to the consumer. So in the particular case of Major today, Strathclyde is the only UK partner in the project, and we've enjoyed contributing to the dairy trial. Originally, there were 4 use cases within the dairy trial, and I'll just touch on them individually. Grazing cow is a tracking system that originates out of Holland, and it really is determining the time spent grazing and the time spent indoors for individual animals, which is really important. Happy Cow is a collar-based system, very much like the silent herdsman, It's a Microsoft-backed company. They're looking at activity profiles and health of the animals in a cloud-based environment. Herdman Plus is where we come in, and I won't labour that one, but we'll certainly go into more detail in a minute. And remote quality is a company that provides services on measurement of milk quality on the farm, and they want to optimize the processes as well. They want to be able to understand if they can calibrate remotely and optimize the service to the farmer. Now, the nature of the project itself is such that it has an open call, and during the open call, people have made bids to join us, and we were fortunate enough to secure 3 other major contributors. An Irish organisation that looked at lameness detection, so they had pedometers on their animals and their ankles, and they're looking at step count, how much time is laying and how much time is walking, and from that developed an artificial intelligence algorithm to determine the level of lameness. Precision Mineral Supplement is a Danish company that has got effectively a feed station that offers nutrients and minerals to individual animals. It measures how long it's been, how much, what weight of minerals it's consumed. Particularly important after giving birth, but there's an energy dip. And then we've got the rumen people from Hungary, the multi measurement cow monitor, which is a bolus that goes into the rumen of the animal and is measuring its temperature, its activity profile, and indeed they can stretch to measuring rumination, the part of the time spent ruminating. So these are the kind of the entity of the whole of the dairy trial, and we all work together and we all feed off each other and share data, and that's in essence what we're trying to do here. So apologies. So what we'll do now, Annabelle, is move on to the Herdman Plus, our particular use case that we're most familiar with, and it's also related to the presentation from Brian Weatherup, who is the test environment within the UK. So I'll hand over to Chris. Chris is one of the main researchers within the group. He's been driving the technology development and interaction with Brian and the rest of the farming community. And Chris is going to walk you through the particular aspects of the use case Herdman Plus. Okay, Chris.
Thanks for that, Ivan. So yes, I'm Chris, one of the researchers from the University of Strathclyde that's been working quite closely with this data for a number of years. The main reason we are looking at this project and looking to develop a solution is that farmers are under increasing pressure to bring more sensor technology onto their farm, whether that's economic, whether that's health concerns. But a lot of these systems don't necessarily talk very well with each other, which means that one, it's more burdensome on the farmer having to interact with 3, 4, 5 separate systems. But 2, you're also potentially losing value. You could combine information from these different systems and provide kind of new, novel, early alerts and ways to make your farm a kind of better environment for you, for your animals, and for your end consumers. And some of this is about more efficient production. For example, if you've got some kind of welfare event that takes your animals out of milk, then you're losing money every day that you're not providing milk from that animal. You're also got the health concern of increased use of antibiotics, which you could potentially drive down. And that's also got consumer effect where if you're looking at transparency down the line, being able to indicate a reduction in antibiotic use could be useful long term. So where we come in is looking at the Herdman Plus platform. This is based on a collar system which monitors the feeding, rumination and activity level of the animal. And this system can run for 5+ years on a single battery. This communicates back to a piece of hardware somewhere on your farm, typically in the shed. And that can be used to both look at the data, but also to prioritize your time by sending alerts directly to you, either at, for example, a home computer or on your mobile where you're out and about. The original use case for this was fertility management. And here you can see the red and yellow traces showing the general activity level of the animal. And you can see on the left-hand side here that we have a strong level of activity, which is the cow coming into heat, with the kind of orange bar at the bottom, the protection of that heat coming up. And this lets you better monitor the fertility of your animals and plan your insemination You can see on the right hand side you've got the second prediction coming up based on the kind of 3-week window, and the farmer's alert that the animal's actually been inseminated. But fertility isn't the only thing that you can manage with these collars, because you have the eating and rumination behaviour shown in the blue and green traces along the middle of the diagram. At the far edge, you see that both eating and rumination drop off simultaneously over the course of 2 or 3 days. And with the farmer's annotation here, we can see that it's a mastitis event. So the animal's feeling unwell, isn't going to the trough, isn't eating, and that's present on the collar. But milking systems are kind of, there's many different sources of information, and the collar itself can tell you that your animal's feeling unwell, but it can't necessarily give you specific information as to what's actually happening. It's just a general indication of a cow needs attention. But if you've got information from a milking system, for example, you have the connectivity per quarter, and each line in this diagram here shows a single quarter of the udder connectivity during milking, with the red bar the farmer's diagnosis of a health event. In this case, we know the event is mastitis, and you can see that just prior to the farmer's diagnosis, 1 quarter rapidly rises, indicating inflammation of that quarter of the udder. But these milking systems also provide information of the content of the milk. And here we see again another welfare event marked in red. And just prior to this, the fat to protein ratio of the milk greatly rises, and the lactose level of the milk greatly drops. Now, the conductivity and the milk constituents, they are measurans that can directly provide information that it may be something such as mastitis, whereas the collar can provide information early that there's simply something wrong with the animal. But you're able to combine these systems together to extract even more value. So you can see here again that in this case at the top, we've got little blips where systems are providing alerts, and then the bottom 2 wider diagrams are the examples you've previously seen. In this case, eating and conductivity are alerted just prior to the farmer's diagnosis, and then this is followed a day later by a rise in the fat level of the milk. And you can combine these systems together to provide 1, 2, or even 3 days early alert based on a skilled herdsman's diagnosis. And this pattern is common across many different instances of mastitis. In this case, again, you can see that the collar is providing an early alert a day before the farmer. That's followed by confirmation a day later with a fat rise in the milk, and then further again by a connectivity rise a day later again. So this can provide reassurance that one system is telling you that something wrong with the animal, a second system is coming a day later to say, we agree that there's something wrong with this animal, and here's a little more specific detail which may help you drill down exactly what it is. And this lets you really prioritise your time and ensure that your animals get the best treatment. So what I've covered today here is mainly fertility and mastitis, but these aren't the only sensor systems that you've got on farm. For example, leg tags are increasingly common, both for registration at your automatic milking systems, but also just for getting a level of activity of your animal. So for lameness, for example, you could combine activity levels such as step count or the amount of time your animal spends lying, along with patterns of eating and visiting the milking robot. For example, it's been observed in some animals that they may eat about the same amount of food, but they'll do it in fewer, larger bursts. Effectively, once they get up, they eat as much as they can and then they lie back down rather than putting weight on a sore hoof. And you can also provide information from the boluses, such as the previous project mentioned by Ivan, to get information on the pH of the rumen, mixed with the level of rumination monitored by the collar to provide indications of acidosis. And just to give you a nice picture here, leading on to Brian, The data that I've represented here is mainly from the Parkend Farm, which is one of the Agri EPI satellite farms located in Scotland. And there's approximately 300 cows, Holstein Friesian, about 240 in milk at any one point in time. And with this being such a very high performing herd, mastitis was quite prevalent, with lameness coming in second, but mastitis was the primary focus here. And obviously, part of this project would like to thank Fullwood and Affimilk and the Agri EPI Centre for the facilitation of done this. I'll now pass you on to Brian so you can hear a bit more about the impact this has directly had on the farm itself.
Thanks very much, Chris. As Chris says, we're here to provide solutions which the farm is comfortable with, and Brian's participation has been invaluable to make the systems much more meaningful and impactful than otherwise it would be. So Brian has kindly agreed to give us the experience of his of using the systems and the impact it's had on his operations and his business. Brian, could you give us a bit of the experience that you had thus far?
Yeah, good morning everyone. Thanks Ivan and Christopher. Yeah, so a quick introduction to what we've been doing sort of basically over the last 5 years. We made a decision about 5 years ago that we had to change some things on the farm just to improve our efficiencies. One of the biggest issues we have is good quality labour on the farm. And really wanted to push the performance of our cows as high as we could. And being that we're a family farm, me and my father work full time on the farm, and then my wife works part time on the farm, and mother does the bookworks and stuff on the farm. So the idea of trying to employ someone to do a lot of the jobs that really have to be done to a very, very high standard was something that we were struggling with a little bit. And we'd looked at technology, robotic milk and stuff like that before, but to that point we hadn't really found a system that we thought really ticked all the boxes for us. And we saw the new Fullwood Merlin robot working, which is now about 5 years old, and we decided that was the way we wanted to go. Round about the same time as that, we fell in with Agri EPI and some of these guys, and we decided to go ahead and invest quite a lot of cash in 4 Fullwood Merlin milk and robots. And working through it with Agri EPI, we also installed the silent herdsman collar system, and take a big jump from where we were then to where we are now. Our yield has improved on the cows by around about 20%, which is a huge jump for us. Coupled with that and all the technology and stuff that we're using, the robots milking the cows instead of milking through a conventional milking parlour, we're saving anywhere between 4 and 5 hours of manpower every day. And it's just those sort of things that make a huge difference to what we are doing, to our business, to our lifestyle. Can just show you how much technology can do. But I actually noticed something on social media the other day. Someone said, why should we just do things the way we've always done them? Because the 7 most expensive words in agriculture are, we have always done it that way. And 5 years ago, we were really not adverse to change, but worried about change, worried about moving towards using more technology on our farm, and having made the investment, having had the experience over the last 4 years, milking cows through robots and using the collar technology to improve our herd, I can safely say it's been a massive step, a massive improvement in our business. So anyway, on the increase in yield, you've got that 20% increase in yield, but that doesn't really tell the whole picture, because we also have less cases of mastitis in the herd. We also have less cases of lameness in the herd. We also have more time to manage the herd better because we have the technology on the farm. On the collars, just to give a bit more information on the efficiency that it helps us with, not only do we have the collars on the cows that are milking, we have the collars on the young stock that then enter the adult herd to milk. And having put the collars on the heifers, we've reduced our age at first calving by 10%, which is huge. It's just over 2 months earlier that our heifers are entering the herd. Now, there's a lot more to it than just the collar data, meaning that we're getting better conception rates and better estrus detection. You know, we also are feeding the cows better. We've got more better ideas on nutrition and stuff than we had 5 years ago even. So our rate of first calvings drop, which is a massive efficiency driver for a dairy business. It means that we have heifers entering the milking herd sooner. It means we have more surplus heifers that we could potentially sell or can enter the herd and replace a cow of poorer conformation. So that improves your herd quality, improves your yield over time, and also improves your bottom line, your profit, because you've got these extra heifers to sell. And also, one of the main drivers for efficiency in a dairy herd would be calving index. So the collars help us with that because it helps us obviously with our estrus detection, helps us get our cows in calve quicker, get them in calve more successfully. Our calving interval at the moment is not any different to what it was 4 years ago, but if anyone who's milking cows or has experience of milking cows will know, as you increase yield, you generally tend to increase calving interval, and that's not to make an excuse that our calving interval hasn't decreased because of the technology we've used, but because the yield has increased by 20% and the calving interval has stayed static, that is a big win for us. On the mastitis that Chris was talking about, a few things that we're doing at the minute. We're getting a lot of pressure from our supermarket contract about reducing antibiotic use, and we're actually using a product at the moment, which I'll not go promoting it, but it's a non-antibiotic holistic product that we're using. That is, we're able to treat now around about 80% of the cases of mastitis without antibiotics. But the main thing that makes it successful is using it early, really early. And so if we can use this data that we've got, if we can get it, you know, in a nice handy place that gives me an alert really early, I can then use this product rather than an antibiotic product. And it's also cheaper than antibiotics as well, which makes a big difference to us. So yeah, there's lots of different things happening that we're trying to do to reduce the mastitis, but if we use the technology in the way that it's developed to be used, it can make a huge difference to us, to the welfare of our cows, to our profit at the end of the day as well. So yeah, in summary, all the stuff that we have, all the technology we use on the farm, much as we were afraid to use it before, we're not so afraid to push forward and think about using more technology in the farm. We already have 3 or 4 different newish technologies on the farm, and we're hoping to work on a few more with Agri EPI soon. I mean, 5 years ago, we didn't really have any technology stuff looking after the cows. Now we've got lots of different platforms already. So I guess in 5 years' time, I'd like to think we'd probably have some more, and we have healthier cows and we have more productive cows. Yeah, that's the goal for all of these technology systems that we use. So thanks for your time. That's me.
Thanks.
Done.
Thanks, Brian. I was just going to ask you, how do you interact with the systems? Is it do you, when you're looking at the collar system or the milking robot systems? So what's the kind of interaction mechanism for you? Because I believe there's some challenges still in respect of you know, getting all the data presented to you in a more efficient manner.
Yeah. So the challenge really for us is that we have all of this data, but most of the time it's in 3 or 4 different places, which is fine if you know where to look. But realistically, if you want to leave someone who's, and I'm not being big-headed here, but we consider ourselves to be good stockmen. If you have someone that's not a good stockman, it's important that they get the alert or the warning to go and check those animals at an early stage, because like any disease, any problem that you have to come across, the earlier you can detect it and deal with it, the higher your chance of success is. So if we could just get all of the systems talking to each other and giving me a really simple alert, be it text message, email to my phone, at some point, if that comes through and I'm on farm, I can get to that animal within 5 minutes, within 10 minutes, within half an hour, and that that can be the difference between a successful outcome from treating that animal or an unsuccessful outcome. And that is really important to us.
So you go to every system and then you correlate them in your own mind because of the experience that you had. But it does help. It does help you target a particular action for individual animals.
Yes, absolutely. All the data gives me a good idea. I've got a fairly good idea before I even see that cow what I'm going to be dealing with when I get there, just by looking at the data and the experience that we've had over the past 4 years of using the systems.
Yeah. So listen, just to reiterate what I said earlier on, the success of the technology and the impact it's had is a large gratitude to Brian for his engagement, and we'll hopefully provide some more functionality for him to make it even more easy for him. So there's a nice thanks very much, Brian. Thanks very much indeed. So what we will do now is Brian's eloquently captured one of the issues that still remains for us, as this underpins this Herdman Plus activity they've been doing thus far. So the integration of all these data streams, there is no technological barrier to it, and we can discuss this later on, but just to demonstrate to you that it's able to be done, I'd like to hand over to Rob from Glass Data. Now, Rob's a farmer's son, so he understands the sector really well, but he's spun out a company, he's established a company which provide data services to the farming community. And I just wanted to make sure that I dispel some of the issues about integration of the data, etc., because this company is doing this in a routine fashion, and I wanted Rob to spend some time and demonstrate some of the stuff he's been doing thus far, which will ease the understanding. Okay, Rob, are you ready to go?
Yeah, thanks very much. And sorry, there's a dog barking in the background there, but I'll go on. Yeah, so I'm gonna provide a real life example of some of the data and integrating some of the data together that Chris was talking about, and hopefully address some of those issues. But just a really quick overview, as Ivan said, my name's Rob Sanders. I started a company called Glass Data about 3 years ago, and our whole focus, our whole ethos is providing a place where different strands, different sources of information can come together. The reason we've done this is we see that the agriculture sector, as I'm sure you're all aware, is being put under more and more pressure to embrace technology, to become more sustainable, to become more productive. And we feel that obviously data is a really important part of that. And without effectively measuring things, you're not going to effectively manage things. But often the problem isn't necessarily not having the data, but as Brian just said, the problem is often having a simple tool or a tool to be able to manage it properly. So what you're looking at here, which I hope you can all see on the main screen, is our web portal. Now this is our product, we call it Glass Core.
Sorry, Rob, we can't see it at the moment. Let me just resend that link.
Okay, sorry about that. Can you see it now?
No, Rob. Have you got two screens open?
No, it's saying that it should be showing it. Sorry about this. Let me try unplugging. Can you see it now at all?
No, just bear with me, Rob. I'm just going to. So it's making you the presenter now.
It's asking me to show my screen.
Click OK.
Yeah. It's asking for permissions to do it. I do apologize. I thought I'd gone through this. Can you try again? Are you seeing it?
Not seeing it.
Nothing.
Oh, I'm going to have to leave the webinar and to rejoin again. I do apologize for this.
Okay, Rob. So let's Craig. Thanks, Rob. If we leave, come back, because it's a really important aspect of what we're trying to communicate. Annabelle,
Sure.
we'll probably just is Craig. Can you put Craig on to present some of the stuff that we are developing as a next generation of suite of technologies that perform certain tasks, and hopefully we'll manage to recover Rob after Craig presents. So Craig, are you there, my friend?
Yeah, I'm there. Can you hear me?
Yep, that's
Yeah.
fine, Craig.
And can you see my screen?
Yes.
Yep, I can see the faces.
Okay, that's good then. So, because the last time I tried this, I managed to have a spectacular fail. So, so that's good. Anyway, right. So my name's Craig Meachey. I'm from Electronics and Electrical Engineering at Strathclyde, and also part of this use case 2.3 silent herdsman. Now, what we have chosen to talk about today, we had a discussion about this last week, and we felt there's a whole range of new technologies that's coming out, from advances in the collar technology for us to be able to detect things like heat stress in cattle, the use of radar technology to measure lameness. But one of the things that was interesting us a lot was a discussion about precision feeding. And what we decided to do as part of the silent herdsman use case was to try and put a benchmark into how effective would a precision feeding technology be in a real life environment. And since we're talking about real life environments today, I thought this is a useful thing for us to give us just an update on. So, we're aware, and Brian has just given us an endorsement of the fact that, you know, there's a range of technologies out there that can use, that were built on the heat detection requirement initially, but they also provide additional behavioral information, and some of that is feeding behavior. And often I've heard people say, well, actually, if you could use that feeding behavior that you could get from the collars as a proxy for the time spent feeding, then if we can use that as an estimate of what the feed intake might be, then that would be something which would be really valuable. And it would be really valuable because it's quite easy to understand what you're delivering in terms of a feedstock to an animal. And if you know the nutrient quantity of what you're, the quality of what you're giving the animal, once you know how much it's actually eating, you've got a kind of real pathway for you to understand what its nutrient uptake might be and identify which of the animals are good or bad performers. And you're right on the way to a kind of precision feeding approach. So what we did was we had a look at, you know, does time spent feeding actually relate to feed intake? And you can see that in the open literature, it's reported that it really strongly does. So this table on the on the left-hand side shows a number of anonymized steer numbers, and the correlation coefficient, which is much larger than 0.9. The R-squared value determines how well the time spent feeding relates to the feed intake for that particular animal. And when on the first instance, it looks absolutely fantastic. So that should be straightforward for us to do. All we need to do is measure the time spent feeding, and we know how much the animal is taking on board. And that's true. That's true if we know the details of that particular animal. But if we look across the herd, and that's what the graph on the right-hand side shows, each individual animal has got a completely different behavioral pattern when it comes to eating. The ones on the left-hand side, A78, for example, goes to the feed trough very infrequently, but has a large meal. As we go to the right-hand side, you get animals that dot back and forth to the feedlot, and each time they go, they don't eat very much. So if you were to apply just the time spent feeding to estimate what the feed intake would be, you're likely to get things pretty badly wrong. So we did a calculation based on, right, if we'd used that approach, if we just said, okay, how long does an animal spend feeding in relation to the rest of the cohort of animals that are in the pen, and then we look at the amount of feed that was delivered minus the amount of feed that was left over, then we can see that what happens is you get a range of prediction errors, and anything from underestimating the feed intake to 10 kilograms per day to overestimating the feed intake to 10 kilograms per day. So it didn't look to us to be a particularly sensible approach. So we thought, can we do something with machine learning? Because machine learning seems to solve everything. You know, you just throw numbers at a black box, and out comes the answer that you want. So that's what we did. And the technique that we used is something called a support vector regressor, and we constrained ourselves with parameters that would be available in a production setting. It's possible for you to identify how often an animal visits per day to a particular feed area. Collar technology ear tag will allow you to do that. It's possible for you to measure, at least at some point, the animal live weight. And you know, if you've got feeding information from a collar, then you can tell how long it's been feeding for. Now that all assumes that the collar or the ear tag or everything is perfect, and we wanted to take that variable out of the equation. So what we did was we used the information from electronic feeders, HOCO feeders that are calibrated. We know exactly how much the animal has taken on board. We know exactly how long the animal has been feeding for, and we know how many times it's visited. So any slight fluctuations from that you might get from a collar or another measurement process that infers that behavior is taken out of the equation. And we used our support vector regressor, and this is a bit of a technical graph which I won't explain in detail, but basically what it does is it fits a boundary between the parameters we're trying to identify, but it fits a soft boundary. It fits a soft boundary, so if I've got lots of measurement points on one side of the boundary and lots of measurement points on the other, it doesn't kind of oscillate back and forth between the two. And so what we did was we used this support vector regressor with lots of measurements of feeding data, roughly 4,000 animal days, 150,000 animal visits to the feeder. And then that gives us enough to do what we call training over machine learning algorithms, and that's what we did. And the details of that are slightly irrelevant, but what you're really interested in is the performance. So this is a performance of the feed intake as predicted by our support vector regressor versus the real feed intake, and you can see that there are two clusters. The two clusters correspond to the types of feed that are delivered to the animal. The one which is at the lower end of the graph is a concentrate feed, and largely these were beef finishing steer, incidentally, these not milking animals, but I guess the same process would apply. The concentrate feed is as it says, much more concentrated. The animals take on board their nutritional requirements using a much lower quantity. And the higher end cluster is a typical forage diet for a steer or a dairy cow, whatever it might be. So obviously there are two different predictors, and we do need to have an understanding of what the feed mix is that's being delivered to the animals in question. But if you know the feed category, what we found is that we're getting quite a good correlation between our prediction and the actuality, and we were able to pull the RMS error, or the root mean squared error, basically how badly are we getting things wrong. We're able to pull that down to what we thought was getting closer to an acceptable value. So if we look at the error on a daily basis across the herd, you can see that it's centered around 0, which is good, and we kind of would expect that, and it's relatively tight, but what does that mean in real life? To give us an understanding of what that means in real life, oh, I have no idea what's happening here. It doesn't want me to present this slide here. It must be top secret. Here we go. what we wanted to do was have a performance predictor, and the performance predictor that we used was the feed conversion ratio. And hopefully, Chris, I've got this right. It's the total intake versus divided by the live weight gain. If we look across the herd, you can see that we've got a number of kind of squiggly curves. On the left-hand side of that, we've got the actual feed conversion efficiency as estimated using the real intake values and the real growth, and the predicted predicted feed conversion ratio as calculated using our estimates of the intake. So one of these is for concentrate and one of these is for the mixed ration. But you can see in both instances we're getting a fairly reasonable agreement. And the challenge is, do we believe what we're seeing? Because we have a look at what our calculations are telling us. Their calculations are saying that the feed conversion ratio that we are predicting from these algorithms is actually looking pretty good. So we fired this into an analysis of our herd performance. And this table is a little bit messy to understand, so I'll take a little bit of time here. What we've done is we've split the animals into performances of good, average, and middle according to how their real feed conversion efficiency panned out. And we've also predicted what the good and the average and the not so good feed conversion efficiency would be. So ideally, what we would like to have is that we would have a good distribution of all of these. But in this case, what's happening is we're maybe slightly over predicting the good feed conversion efficiency, but we never ever convert a good, sorry, what I'm saying, I've got this slightly wrong here. In each one of these things, we should have 26 animals.
So, Craig, I think you need to finish off soon, pal.
Yeah, so it's fine. I'm finished this. In each one of these areas, we should have 26 animals. We've actually predicted 18 of them correctly in the good category, 15 correctly in the average category, and 23 correctly in the poor category. And in no instance were we out by more than one category. So with that information, you're able to get a good understanding of how things performed. And apologies for taking too much time.
No, you're all right. It's just I'm hoping that. Thanks, Craig. That's a part of some of the stuff that we're doing based on the data we've got so far. We're eking more information out, so that's brilliant, Craigie. So
it's all right.
Is young Rob on the line now, Annabelle?
Yeah.
Hope so.
Yeah. And yeah, we now see the login, Rob. That's it.
Yeah. Carry on,
okay,
Rob.
Brilliant.
Thanks, Craig. Thanks.
Okay, yeah, sorry about that. Typically, the tech demonstration decides to go wrong, but there you go. So, just a quick overview. What I'm going to do is I'm going to show you a live demonstration of integrating some of the data that Chris was talking about earlier. So obviously, this has implications with early detections and specifically with mastitis in this case. But just as a really quick overview before we get into it. We're GLAS Data, and what you're looking at here on the screen is what we call GLAS Core. And this is our product that is designed to be able to aggregate data from any source, but it's focused on agriculture. What you're looking at here is the web platform. We also have a mobile app in beta, so it's invitation only at the moment, but we're focusing all our efforts at the moment on what you're about to see. So if I just log into this here now. So the system is designed to be really kind of focused on exactly what you want to see. Okay, so no two farm businesses are identical, although there are obviously commonalities. So when you log in, you're taken to this screen here. Now, what I'm showing you is a completely fresh account. So we've only got the data that we're focusing on today in here. But this is where you'd see all your visualizations and all your graphs that you set up that are telling you interesting things about your data. And as part of this demonstration today, we'll be setting one up. But the system focuses primarily on three main data types, and I'll show you as we navigate through the system exactly what those are. You'll notice here on the left, I've got a kind of menu item with a lot of different sections that you can go to. and one of these sections here is just called My Data. So if we click on that, you should be now seeing a screen with several different cards on them. And again, I'm going to explain exactly what these are and what you're looking at. But for the time being, I'm just going to click on one of these, and we'll see another screen with yet more cards. And again, I'll explain this in a second. But if we drill down into one of these, you'll see what looks very much like a table, something that you would see perhaps in a system like Excel. Now, this is one of the strands of information that our system deals with. We call this free-form information, and you get a lot of the behaviors that you would out of a spreadsheet. You can create functions, you can perform mathematics, you can manipulate the data. Okay, so this is strand one of the type of information. The second type of information is mapping information. So I'll very quickly show you our mapping module. And again, because this is a fresh account, you're seeing a blank space here. But what we can do is we can import fields and shapes and pins and put them on the map. And then what we can do is we can link them back to the topics of information that you saw just a second ago. We have an integration with the Rural Payments Agency here, so you can enter your single business identifier, your SBI number, and bring in your registered fields automatically. And we also just have a more generic shapefile importer. So if you're using other existing mapping software, you can bring in those fields rather than sort of recreating the wheel, because we're all about aggregating data, not recreating it from scratch. But if you don't have any of that, you can just draw things on the map, and you can drop pins and things like that. Once you started to link up your data, you can then click on that. You can see which data is linked to any given spot on the map. You can see graphs, and then you can jump to the raw values. And then finally, the final strand of information we focus on before I give you a focused demo is Internet of Things devices. So again, I'll explain what this is in a second, but if we just look at the integrations, some of the integrations we provide, you'll notice a card here called IoT Device Connect. Now, this is relevant to what Ivan was saying right at the beginning of the webinar, but we've got now over 70 different sensors from different suppliers, all integrated into the system. I won't go through exactly what they are, because most of them measure more than one thing. So we've got quite a few different data points that can be measured, but this whole plugin here, this whole integration is designed to automatically bring that data in, and it all appears in the same system. You can see here that we've also got integrations for the Cattle Information Service and the National Milk Records. Here's the RPA, the Rural Payments Agency that we saw earlier, and we have one for a company called Kite Consulting. And in collaboration with Strathclyde, we're going to bring 2 more integrations, 2 more cards to screen, focused specifically on the 2 systems, which I will now show you. So if we go back to the My Data section, these cards that you're seeing here are what we call topics. And each topic represents a particular piece of information. Okay. Now, in this case, we have 4 topics. We've got 2 coming from a full-wood milking machine, which again, Chris was talking about earlier. So this is the milk quality information here on the left. Then we've got the activity information. And then we have 2 further topics from the AFI milk collars. So we've got the hourly activity information, and then we've got some further activity information here, 1 row down on the left. If we click into one of these topics, so if I go into the milk quality, we get a further screen, and these are made up of what we call assets. Okay. Now, an asset is any physical item on your farm business or in a processing unit or any agricultural business. In this case, these are cows, because we're doing dairy information. It obviously makes sense to do it cow by cow. So you can see here that we've got asset number 2323. This is cow 2323. And if we click on her, we can then see the milk quality information. So we've got the protein, lactose, fat protein ratio, fat, the duration of milking, and then the bloods. And then also we've got a column here on the right on conductivity, which at the moment for this individual animal is blank, but as the data comes in automatically, that will populate. If we go back to the My Data section, and we have now a look at the AFI milk data. So if we click on the AFI milk hourly topic, you'll see that we get a similar screen full of assets. And if we just search for cow number 2323, here she is. So this is exactly the same animal. And here we go. We've got, if I just expand this table out, we've got about 2 days worth of sample information here from the 11th and the 12th of October. And we've got eating scores, rumination scores, and then a column here just called other as well. So you can see that already we have, it's very trivial using a system like this to bring in data from two different systems, and we're looking at it here. We don't have to log into anywhere else, but that's really kind of just the basics of it. The real interesting stuff starts when you start comparing it and bringing it together and really starting to see what the picture's telling you, to give you that kind of overall more holistic view. So the top two links here, we've got the dashboard and then we've got the create visualizations. And what I'm going to do for the remainder of this demo is just walk you through creating a visualization and pulling in the information from those two different systems. So to start with, and again, I'm not really kind of focusing on anything in particular here. Let's just pull some interesting stats together. So let's do something from the full wood milk quality, and let's have a look at the protein, the lactose, and the fat levels for that. And then if we also have a look at the hourly information from the After-Milk collar, and let's have a look at the eating and the rumination scores. Okay, so now we have to fill in a few questions on the left here. So the first thing is over what time range do we want to see this data? Now this sample data is from the 11th to 12th of October. And because I have prepared slightly and I know this data, it starts at 6 p.m. in the evening. So just to make the graph look a little bit nicer, I'm going to set the start times as 6 p.m. So we've got 6 p.m. on the 11th until 11:59 p.m. on the 12th. I'm just going to confirm that. And then what we're going to end up with is a graph where on the bottom here we're going to have times, and on the left here we're going to have values on the y-axis. And I would like to have a point on the graph for every hour in that time period. So let's preview that and see what it looks like. So we have quite a messy looking graph here, and you can see there's a chunk of time here where there's some data missing. The reason for that is what's going on is we're seeing averages over the entire herd, but that's not really that useful. So what I think I'd quite like to do is have a look at all these different pieces of information, but on an animal by animal basis. So we can do that quite easily. We don't want to look at times on the bottom, and what we want to do is we want to have a look at what's called asset view. Now, if this is sort of sounding a little bit complex, we do have a whole website dedicated to tutorials and helping people set it up, and we actually have members of staff who are dedicated on sort of talking people through this, and once you've done it a few times, it becomes easier. What I'm going to do also is I'm going to change these to be bar graphs, just because it looks a little bit nicer when we're comparing animals together to do it as a bar graph. So I'm just going to flip those over like so. And then also you'll notice that I've got a data action set to average there. Now, if you're visualizing something, for example, like the volume of milk being collected, you might want to set that to total. But for the time being, because of the things that we're looking at, I think average values are most appropriate. So let's have a look at that if we preview that now. And you can see here it's a little bit better. We've obviously got a lot going on here, and that's because we've got about 160 cows that we're looking at all in one graph. But what we'll be able to do in the next screen is we'll be able to drill down and have a look at a few of the animals side by side and really see what this is telling us. So let's go ahead and create this. And this will take you over to the main dashboard. And now what you're seeing here by default is just the first animal in that list, which is cow number 1372. And here is all the information. So we've got the protein, the lactose, and the fat levels from the milking robots. And then we've got the eating and the rumination scores. Now, if I pull up all the y-axes here, you can see all of those different axes are showing different values. But what I quite like to do is see how all of these things relate to each other. And again, this is all explained on our tutorial site. But what I can do is I can just click fix that y-axis, hit confirm, reload the graph, and now you can see that we are visualizing how all of these things are related to each other. So we have a slightly smaller protein and fat levels, slightly higher lactose levels, and then the eating and the rumination scores are obviously larger values. We were looking at cow number 2323 earlier, so if I go back and search for her, let's have a look at what she looks like, and I can just click on her like that. Here she is. And now we notice that, for example, the protein value here is actually a little bit smaller than the other ones. So I'd quite like to see how she compares to some of the other cows in the herd. So let's bring in some others as well from the left. And I'm just going to get the first sort of 7 or 8 here. Let's bring them in and update the graph. And there we go. So now we're looking at, I think there's about 9 or 10 cows, and we're looking at data coming in from 2 different systems. We can see that cow number 1573 is actually missing information from the full wood milking machine, so we can get rid of her. Let's clear the graph and update that. And there we go. So now the interesting thing here, and I actually only noticed this when I was sort of playing around with this information, so I don't know if there's a correlation here, but we're starting to see, for example, that the animals with a low protein level So here we've got protein of, or lower protein level. Also have a pattern where their eating scores are higher than their rumination scores. So you can see we have 3 animals with that pattern. And then we've also got the same 3 animals with a relatively low protein scores.
Rob,
and then the higher protein scores.
Sorry, Rob, can you start finishing off?
Absolutely, sorry about that. I'm almost done. The higher protein scores, you can see that the rumination is significantly higher than eating. Now, what this enables us to do is just to start identifying trends and patterns like this, okay? And it hopefully will give people a deeper insight into what's actually going on within a single animal or across the herd or indeed over the entire farm. And that combines with our alert system that Brian was talking about earlier, where you can get text messages sent out, emails sent out when particular values pop up that are indicating that something's going wrong. Anyway, I'll cut it short there and hand back over to Ivan. Thank you.
Thanks, Rob. I mean, it's typical technology let us down, but basically, what Rob's saying, that's a work in progress. He's managed to get all the data in, and where he'll start to really get power is when we start correlating and using advanced software to correlate between these different ones and produce the alerts that Brian is a call to action. So thanks very much, Rob. That was really impressive, and we're working together to get Brian's farm plumbed up all this software to help them visualize it easier. So let me introduce Gavin Dick from Agri EPI, who's the farm manager, looks after all the satellite farms. And just to invite him to summarize some of the things we've been talking about today before we end the webinar. Gavin?
Mute, Gavin.
This happens every time. Can you hear me now? Thanks, Ivan. So yeah, it's my role today really to thank the presenters for their effort, and really just to put a message on what you've heard today. You know, I've been sitting in quite a lot of these webinars over the last few months rather than getting out onto farm, and it sort of strikes me that an awful lot of the stuff that's being developed and delivered is individual bits of technology that do something on their own, and that really has very limited value to the farmer, because the farmer has to consider all the different elements that go into what's impacting on a cow's health, productivity, fertility, whatever. And so what really struck me today was that not only did you have the individual bits of technology presented by Strathclyde at the beginning and how Brian uses them, but actually we finished off with bringing all these things together. And that's the real value of data, is where you start to integrate them. And I think, you know, Brian mentioned a couple of things that struck in my head, and one was about, you know, how good stockmanship is really important. And I can't remember the exact words he used, but my phrase is "I done." And one of the most costly mindsets in agriculture is the "I done" mindset, where you just do the same thing all the time and you're not open to change. And I think we really have to be open to change, but we have to ensure that good stockmanship is pulled forward and actually enhanced. And I think that's what today is showing, that technology, when it's integrated together, can actually enhance stockmanship by actually allowing the stockman or the farmer to make a much better informed decision through the detailed data that technology can deliver, and at a much earlier stage in the production process than what a human brain can actually deal with. So at the moment, the old way of doing it really was you looked at all your data sources, whether it was a piece of paper or something recorded in a machine, and the stockman has to make that, he has got to interrogate all these different data streams and come up with an action. What today has shown is that actually technology can go the whole hog and can actually do the interrogation and deliver these actions for the stockman or the farmer automatically, and all the stockman has to do is say, yeah, that makes sense, it fits with my system, and I'll do it. And to me, that's what precise farming is all about. It's not about yield maps or robots or whatever. That's just the vehicles that allow precise farming to be undertaken. And precise farming is about that live management information at an individual unit of production level, which allows the farmer to make much better and accurate decisions at a much earlier stage in the production process. And I think that sort of definition of precise farming is going to become really important as we go forward over the next few years, with the change in the support systems, with the need to address climate change, greenhouse gas emissions, soil quality, and ultimately changing consumer needs from the circumstances we're currently in. So again, I'd just like to thank all the presenters for an insight, well, for me anyway, an insight as to how farmers might have to or could manage their businesses going forward. So thank you all.
Thank you, Gavin, and I just echo my thanks to Agri EPI and Annabelle for establishing this webinar and delivering it. So despite the slight technology hiccups, I think we've achieved exactly what you've said, Gav, is to make sure that we debunk some of this technology, misconceptions, and make sure that the farmer is supported in his operational day-to-day stuff. So my thanks to all the speakers, myself, and bye-bye from us.
Thanks all. Some questions that we didn't manage to answer, we'll just send those on to the speakers and get those answered for you. And just up to now to end the webinar. So thanks.